Hallo und willkommen zum Google Developer Day in München. Thank you. My name is Sumit Chandel. Unfortunately, the rest of the presentation will be in English. I didn't continue my German courses, so I won't be able to continue in German. But the good news is that as I go through this, if there's anything that I cover too quickly or any questions you guys have during the presentation, please just raise your hand. I'll be happy to answer during the presentation itself. We have more than enough time, so please feel free if there's anything that I haven't covered properly. Okay, so just to kind of get a show of hands, how many people are familiar with GWT at all, or have heard of it before? All right, and how many people have used it already for building an application? Okay, all right, so I think with the numbers I've seen, first of all, can you guys hear me properly? In the back, can you guys hear me? Is that fine? Okay, cool, all right. Yeah, so I think that kind of warrants a little bit of a tour. I'm just going to do maybe a 5 to 10 minute intro, just for those who aren't familiar with the platform, to kind of explain what it is before I go into the advantages. So as you can see, the title of the talk is GWT, the Technical Advantage. What I'm going to go through today is all the different advantages that the platform affords you, and some of the implementation details behind what makes those advantages possible, and also how they're pluggable. So things that you can do to plug into some of the architectures that we're using in GWT as a platform that you can take advantage of to improve your AJAX applications. Okay. So Google Web Toolkit. So at a high level, Google Web Toolkit is a set of open source tools and libraries for building large-scale, highly functional, highly interactive, very sophisticated AJAX applications. So actually, it's the kind of thing that only a few years ago, you'd only expect to see on the desktop, except now running in the browser. So the truth is, the browser is actually capable of running these kind of applications, these very large-scale, ambitious kind of applications. If you guys have seen the London keynote, unfortunately today we didn't have time to present too much on GWT, but on the London keynote there was a demonstration of this application called Lombardi Blueprint, built with GWT, just to give you an idea of the kind of scale, and you guys can look at that up afterwards. But anyway, it's for very large-scale apps. Now, the problem is when you're trying to build those applications, you don't have the right kind of tools and the right kind of leverage around the problem of AJAX development. So, if you get bogged down by handwritten JavaScript hacks that you have to code in, different DOM implementations on the browser, et cetera, if you spend all your time on that, then you have less time to actually realize your vision for the application you're going to build. So GWT, again at a high level, what it's about is building your AJAX application using the Java programming language, and then from that Java source, generating the JavaScript and HTML that's compliant to a bunch of different browsers and deploying that on your web server. So referring to the diagram I have up here, on the left, you guys see a bunch of icons for different IDEs. So some of these might be familiar to you. Those are Eclipse, IntelliJ, NetBeans, and that kind of thing. So if you've used any of these IDEs before, you kind of know what power is available to you there. And with GWT, the idea is that because you're coding in Java, you get to utilize the power there to build, instead of a desktop application or a Swing application, you get to actually build an AJAX web application with the tools that you have there and the power you have there. So that already gives you a lot of leverage around the problem of building large-scale AJAX apps. On the right, you see a bunch of different browser icons, one of which you probably use every day. Those are the set of browsers that are automatically supported by GWT. So you code your app, and it'll work on any of these browsers automatically. That's actually not an exclusive set. Yes? Chrome, I need to update the... yeah, I'm sorry. Okay. Actually, if you guys might recognize this graphic from the keynote this morning. They actually showed it very briefly. And in that version, there was a Chrome icon. So I just didn't have a chance to update my slides here. But yeah, Chrome is included, definitely. So thanks for pointing that out. Yeah, it's in there. Yeah. Actually, so what I was going to say is this isn't actually an exclusive set of browsers. And the whole WebKit family is supported. So as you guys might know, Chrome actually uses WebKit. So that's automatically supported there. But also Android or iPhone, they all use different builds of WebKit, and your application will automatically work on those platforms as well. And in the middle of the diagram, you see the GWT optimizing cross-compiler. What that does is take your Java source code in and then generate the highly optimized and obfuscated JavaScript that you just deploy on your server. So to have another look at it, what the development will look like is you're coding in your IDE against UI libraries that are exposed in GWT. These look very similar to kind of swing widgets and listeners and that kind of thing. So if you guys have ever developed with that, it's a very similar concept. And if you haven't, it's pretty intuitive to get into. So you code up against that. Once you're done coding your application, you invoke the GWT compiler over that code. It reads in your Java source and then generates the JavaScript. And then produces some JavaScript and HTML files. You just deploy those, and then you're on your web server and you're ready to go. Now that's kind of, again, a high-level type of thing. So I wanted to go in a bit more detail to give you an idea of what GWT development or GWT development. Sorry if I say GWT a lot. That's the way we call it within the team, just as a shorthand. So if I say GWT or GWT, it's the same thing. So just to show you what development looks like there, here is a GWT application I have open in Eclipse. It's a very simple application. It's one of the samples that actually ship with the distribution. So, not to go too deep here, but you can see I have a bunch of different classes here. These are all different widgets, right? If I go into this code here, you'll see I just have things like a top panel, a vertical panel, etc. All these different widgets that I create and instantiate in this entry point class. So just to give you a quick idea of what development looks like there. And then once you're done coding this, you generate that JavaScript and HTML I was telling you about. Now, I ran the GWT compiler earlier on this project, and I generated the output in this www directory. So if I open that up, just to show you what got generated from this Java code, you'll see that it's just a bunch of .cache.html files and .png files, and then this nocache.js. You'll notice that these files have pretty weird names. There's a reason for that, and I'll kind of explain why they're named that way a little bit later. But as you can tell, there's nothing special. From the Java source, it's just HTML and JavaScript, and that's it. Right? So that's kind of half the equation, because, building an AJAX application is one thing. But when it really hurts to develop with an AJAX app is when you have to debug it and something goes wrong. So if you've done handwritten JavaScript before, you kind of know what debugging that is like. How many people have actually done that before? So would you guys agree with me that it's kind of like hell when you're trying to debug that, especially when you're trying to debug it for cross-browser compatibility? Right. So that's something else that we considered when building GWT. So how do you debug a GWT application then? So you code it in Java. What does the debugging look like, right? Because it's just JavaScript that's getting generated. So do you debug in JavaScript or your Java code? How does that work? Well, you actually debug in your Java code as well. So even for your debug cycle, you have access to the tools that are available in IDEs and other Java tools during the debug cycle of your application. And what makes that possible is something called hosted mode. So I'll present that to you guys. So this is the hosted mode browser. Okay, what you're looking at is an embedded instance of the operating system's browser, in this case, Internet Explorer. So it's an embedded instance of that running in this hosted mode process. Now, what's going on? Because this is embedded, it's not actually JavaScript that's running here. It is JVM bytecode that's running. And what's going on is that bytecode is being run by the hosted mode process, and it's giving instructions to the embedded browser on what to render and what to show. So here you can see this is the mail sample application, right? It's very functional. It has all these AJAX-y features, just as a quick sample of just a simple application. And this is that project, the code that I was navigating earlier in Eclipse. This is just that project being shown here. So now I'm going to debug this, seeing what the application looks like here, and at the same time debugging it in my Java code. So if I go back here and switch to my debug perspective, you'll notice that here I have a breakpoint set in this contacts code right there. What that corresponds to in my application is when I click one of these contacts here, it's going to bring up a pop-up that's going to be a contact card with some information there. So that's what's going to trigger that breakpoint. So I'm going to click on this, and then it'll hit the breakpoint in code. And let's give that a try. So 1, 2, 3, pressed it, and there you go. You can see I'm in the debugger now. Let me just minimize this a bit. So there I am. So now I'm in the Eclipse's Java debugger. Here you have the stack trace. You've got variable inspection, all those kind of things. You'll also notice that for the widgets that we use in GWT, we have a stringified version of their DOM construct here, the thing that I'm highlighting. So as you're debugging, you can also see what the DOM construct is for the different widgets that you're using, if you so choose. So you get all those nifty features, and you can jump through the code, right, just like any other debugger. And if I continue here and I come back to my app, you can see that the contact card came up. So that's the idea, is that I'm seeing what my application looks like as I'm debugging it. So when I encounter a bug, I have all the power of my debug tools and my Java debugger tools to help me out here. All right, so now that's what good development looks like, how you'd actually go about developing an application. And now I'll get into the meat of my talk. And before I do that, does anyone have any general questions before I get into some of the advantages of this approach? Okay, all right. All right, so what are the advantages of this approach? Well, for one thing, and this is actually the primary benefit of GWT, is you get faster AJAX applications. That's the main thing about it. When you're making an AJAX app, the idea is to create a better user experience. If you're going to create an AJAX app that's going to go slowly, you might as well have just stuck to Web 1.0. So that's the thing with GWT, is that faster AJAX apps. Now, how does it do that? For one thing, it's faster than you could write by hand code. So what that means, it's the code that you wish you could have written, and you might have been able to write it by hand, but that you can't because you'll run into a lot of cross-browser issues. And it's stuff that you just can't spend time thinking about while you're trying to realize your vision for the large app that you're trying to build. So here's a quick example. In the first code box you see there, that's just a regular button that you're creating and setting text to. So that's what your Java code looks like there. Now, can anyone in the room tell me what the most efficient JavaScript implementation for that is? All right, it's good that no one raised their hand, because it was actually a trick question. Because the most efficient implementation depends on which environment you're running in. Internet Explorer, Firefox, etc. So looking at this code snippet, and this second block here below, this is what the code looks like after a few passes by the GWT compiler when you invoke it and it starts running over your Java source. So you can see here, this is still Java code. And you can see here there's a DOM impl IE6 kind of thing going on here. What that is, it's a substitution of the code that you've just written up for IE6. So the GWT compiler, when it starts trying to optimize and obfuscate the code, it subs in implementations depending on which environment you're in, and plugs in the most effective implementation for a given browser. And after a few more compiler visitors at the end, this is kind of what you end up with, that JavaScript code there, right? So this is a very, very simple example. It's just a button, and I'm setting text on it. So nothing too special there. But you can imagine that AJAX apps are much more complicated than a simple button. And as things get more and more complex, you need good leverage to be able to optimize what you're writing. So for this particular example, so you could have written this by hand, right? This isn't very complicated code. The challenge is that you'd have to change it for every other browser. That's already one thing. The other thing is that you could have hidden it behind an abstraction. So a lot of other AJAX libraries, actually that's what they do. They're exposed as JavaScript libraries. You make calls in JavaScript. And under the hood, what's going on there is that it's actually making delegation calls to say, OK, if I'm in IE6, then use this implementation. If I'm on Firefox, then use this one. So a lot of AJAX libraries are doing that, and you could do that as well. But because you're going behind that abstraction, you're adding function calls to your AJAX application. And that's stuff that your user is going to pay for. So if I'm a Firefox user and I want my application with Dutch messages, why would I also have to download all the IE7 code or all the English messages, for example? if I'm downloading that and then the code that's running is doing checks on that kind of stuff, why am I paying for that as a user of the application? I want just a fast experience for whatever service I'm using. So that's the downside to trying to write this stuff by hand. Now, what else is interesting with the GWT compiler is that you get free optimizations. Now, what I mean by that is that you're coding your GWT application in Java code. And when you invoke the GWT compiler, it automatically takes care of optimizing your application. So it's another thing you don't have to worry about, because if you're doing handwritten, you have to worry about that kind of stuff, because it's all your handwritten JS. You have to be worried about, is this most effective on whichever browser, whichever platform? In this case, you don't have to. As we move between versions of GWT, from 1.4 to 1.5, et cetera, we introduce more and more compiler enhancements from one version to the next. And what's nice about that is that all you need to do for your GWT application to take advantage of the new enhancements is just recompile with the new, update your code and recompile with the new compiler. And then you automatically get the benefit of whatever enhancements we've introduced. So one point to make about this, though, is that just because the GWT compiler is doing these optimizations for you, it doesn't mean that you can just ignore good programming practices in general, right? So those things apply just like in any other language. And a Java compiler also won't compile something that won't be able to optimize something if it's an inefficient algorithm, if you've got redundant objects, extra information being carried around between objects. That's just bad design. So you have to watch out for that. And that's general programming practices. The other thing is that specific to the web environment, to your target deployment, the place where you're targeting for deployment, CSS complexities factor in quite a bit, and elaborate DOM constructs and so on. That's something else to watch out for. In GWT, we actually have a DOM API. So it lets you use the document etc. thing that you'd use in regular JavaScript, except within your GWT code in Java. So you can create your own kind of advanced structures if you need to, if there's a widget that's not supported in the library itself. But when you're doing that, make sure that the DOM construct you're making works effectively on every browser you're targeting, that you're expecting to target for your application, because you will run into runtime issues. Okay, another major advantage that makes for faster AJAX applications, or another technique, is something called deferred binding. So as I'm explaining that concept, and as the team came up with that concept, the question that we asked ourselves is, why give the user more than they asked for? So it's kind of going back to the example I just said earlier. If I'm a Firefox user that wants Dutch messages, why would I download all the extra code if I just need that stripped down version of code for Firefox with Dutch messages to work on my browser? So deferred binding is something that allows your users to only download that bit of code they need to run your application, right? So deferred binding, what is that exactly? Well, to read this very dry definition, it's a technique that lets the compiler make different bindings for your application at compile time and choose the right one later. So that's what it is. The GWT compiler, it runs over your code, and as you saw earlier, when it subbed in an implementation, going back to that other example, you saw that DOM impl IE6 subbing implementation, that first code example I showed. It subs in implementations and then generates different versions of your application, right? So it'll generate a version that's Firefox English, Firefox French, IE English, IE French. It generates one version for each decision point in your application. It then generates an application bootstrap process, an application bootstrap process, which is just more JavaScript that selects the right version of your application when it's loading. So deferred binding is a little bit of a strange concept. So here it is kind of shown in a diagram to give you a better idea. So here you have your single Java code base, that's your GWT code base, and here are all the different versions of your application that are generated. Now, you'll notice that you see those weird names here again. So let's just kind of see what it is live in the generated output for this mail sample application. So if I go back here, so here's the generated output for this GWT sample app. So you can see there's all these weirdly named .cache.html files. What those are actually the different versions of your application, This one here, it's much more strongly named, much more properly named. And you can see it's com.google.gwt sample mail.nocache.js file. That's the bootstrap loader. So what this looks like is you have your main HTML page, in this case your mail.html page. And there's not really much special going on here. There's just this script tag that's sourced to your bootstrap file, right? That bootstrap file, it holds the information of, so when this loads up in your user's browser, it's going to detect, okay, what locale are they in, what browser are they in. Based on that, it has a table in the bootstrap script itself that looks up for some given browser and locale, this is the right version of the application to pick, and then it's going to pick up one of these versions of your app. So it just picks up that, and that's the stripped down code that's specific to the browser and environment. The other thing you'll notice with the names of these files is the .cache suffix at the end, or the no cache suffix in this case. What that signifies is that when you're serving these resources from your web server, you can safely set the cache headers on the resources you're sending out such that the versions of your application that are generated can be cached forever because they have this MD5 sum naming. So that weird naming that I said I was going to explain, I'll talk about it now. What that is, it's an MD5 sum of your code. So that means every time your code changes or you have fresh code, new versions of these files will be generated with different names. So then you have a freshness guarantee, which means that as long as your code doesn't change, why should your user have to fetch these again? So you can cache these permanently, so that as long as you don't have a code change, your users always fetch from cache instead of doing a round trip all the time. That's another huge improvement to performance for your application. Now, the bootstrap file has a very important no cache suffix attached to it. That's because you're never ever supposed to cache that. If you cache that, your users will never get the new version of your application. That has to be fresh because it always holds the latest information for the latest generated versions of your application. All right, so that's deferred binding live and how it plays out in the loading of your application. And now deferred binding in code. So we've seen what deferred binding is. It's generating different versions of your app. But how does that actually work? So in this example, you have we're showing you the request builder class and the HTTP request implementation, which is essentially an abstraction for an XHR, an XML HTTP request. And as some of you might know, that differs from browser to browser. So it's something we've decided to abstract. And this is a decision point for the GWT compiler to know what versions, that this is something that's going to generate different versions of an application because it has different implementations. So the magic call is this gwt.create. That's the magic call that tells the compiler, all right, I'm about to instantiate a class, and this is a class that actually has different implementations. There's decisions to be made based on what I'm going to generate from this class. Underneath that, you see this HTTP request.gwt.xml file. Those are the rules for the compiler to look up for the class that it's trying to create, right? So in this case, you can see that we have a general HTTP request implementation class, and that's the default class that we use. However, we have this rule whenever the user agent is IE6, meaning that we're loading for an IE6 user, use this class instead. So replace with this class when type is this class, when property is this class. And that's how you specify it. So this is stuff that's all going on, again, under the hood in GWT. You don't really have to mess with this code. It automatically works for you. But what is interesting is that this is a pluggable architecture, meaning you can sub in your own deferred binding decisions as you see fit. So let's say you have an application that has some Flash components, or you have an application you're serving to both Flash users and non-Flash users. So people who have Flash can use that component. Others, they just use the regular web application. If you have widgets that interact with that Flash application, you can insert a deferred binding decision here that says, OK, I'm creating a widget here that has different implementations, whether this user has Flash or whether they don't, because this widget might have Flash interactions to do. So you can actually include that here, specify a property that says if Flash is available on this browser, sub in this implementation instead. If not, then don't. And then that way, you're not forcing your users, again, to pay for any code that they're not going to use. So they get a smaller download for exactly what they need. The same goes for Google Gears. And especially if you have an offline version of your app, that becomes pretty important because it's very likely that you'll have different implementations. And you can plug that in here as well as anything else for Canvas, for example, or et cetera. All right. Another one of GWT's advantages is that you get to skip the browser quirks. So as I was saying, GWT automatically supports that set of browsers that I was showing earlier. And you don't have to worry about whether your application is going to work on those or not. They will automatically because of what we're subbing in. So here's an example of a pop-up panel, right? Let's say you want to make a pop-up panel and just center and show it. This is the code that you would write, the first block you're seeing, and that's all you'd have to care about. What's going on under the hood is the GWT compiler is subbing in an implementation, in this case, pop-up impl IE6 for Internet Explorer. And for showing a pop-up, it's doing some really weird, this is one of those JavaScript hacks. A very simple one, but you can see what kind of things you're avoiding by skipping these kind of things. So in this case, for a pop-up in IE6, you have to source the frame to nothing. This is just nothing. Otherwise, IE6 complains of a mixed content warning for any pop-ups you have. So it's just one example of the kind of headaches you're avoiding, and this is actually a simple one. This amplifies enormously as you try to make more and more sophisticated widgets. All right, another advantage, no more memory leaks. So we have someone on the GWT team, Joel Weber. He spent a lot of time analyzing how memory leaks occur in JavaScript, and the truth is there's at least 12 ways that I know of, and he knows of probably more, that you can leak memory in JavaScript, right, when you're coding, especially when you're crossing the JavaScript and DOM layers. So he kind of researched that before he even joined the GWT team. And then when he did, he brought all that knowledge into the implementations we sub in. What that means is if your application consists entirely of GWT code, it won't leak memory, right? So that's the guarantee we're making. Now, the chances are that you'll have to escape to JavaScript now and then, especially if you're interoperating with other libraries or you're working with JSON data. And in those cases, you can escape using JavaScript native interface. That's a kind of native method you can declare in GWT when you need to code in JavaScript. But when you go to that level, just be careful to make sure that you're not leaking memory. And that's the places where you'll most likely will leak memory in a GWT application. So one reference I would point you guys to is the article that Joel Weber wrote on memory leaks. So it should give you an idea of the ways you can try to avoid memory leaks if you do end up coding in JavaScript. But in every other case, GWT has got your back, and it'll make sure that your app isn't leaking memory. Okay, another major advantage, history support. So how many times have you guys used Ajax applications and you're clicking through tabs and then you're kind of scared to press the back button because you're not sure what's going to happen? And the truth is, I'm even scared sometimes because you really don't know what's going to happen unless you see a tokenized URL. But if you don't see that, there's really nothing in the browser stack because an Ajax app isn't a new page that was loaded. It's a re-rendered DOM. So because of that, if you press back button, you might just go back to the Google search page or some other page, wherever you were before. Well, if you're building an Ajax app, you actually have with GWT, you have an easy way of providing history support for your application using the history interface, which is just an implementation of really simple history. It's a protocol that there's details about it online. It's a system of using tokenized URLs that represent history states of your application, and then pushing those tokenized URLs onto the browser stack so you can pop them later when back and forward events occur. So in this example, you're creating a tab panel. It has 2 tabs, and you want to be able to support history for this. So if someone clicks on one of these tabs and they click back, you want to go back to the first one. So here you're adding a tab listener, right? That's just something that's listening for clicks on the individual tabs. And whenever one gets clicked, you're making this call here, history.newItem. And you're pushing this token here, this page with the tab index there. So this is, you come up with your own mechanism for what a tokenized URL looks for your case and what the appropriate history mechanism for your application is. In this case, it's just a page with the tab index. Then later on, I'm adding a history listener. It's an anonymous history listener, but its responsibility is to handle history events occurring in that tab scenario. So on history change, this gets fired whenever a back or forward button gets pressed from the browser. And it pops out the history token that was put onto the browser stack here. And then I check here if the token is valid. That's code that I implement for whatever validity means for me. And then based on that, I select the tab based on what's encoded in the history token, right? So it's a pretty simple example. I hope everyone's following on that. Is everyone okay on that? I had some problems with the Paris GDD, so. All right. Okay, cool. So that's that. So that's how history support is implemented. Another advantage, and I'll have a summary slide at the end of this because I realize I'm just going through tons and tons of advantages. These are some of the more technical ones that I thought would be interesting to kind of expose in a talk so I can get into some of the details of what's going on with how these things are being realized. You can find some of these in bullet points on our code site, but they won't go into as much detail because it's kind of hard to say really fast apps because of this and that and this and that, and then go into the details from the code site. So another advantage is code reuse. So Java in general, and GWT development by extension, is very amenable to design patterns. So you might be familiar with some of these: observer, mediator, and strategy, and all these gang of four patterns. Some of these apply more often for UI development. So you'll probably encounter mediator pattern a lot more for if you're doing either desktop or a web UI. One pattern that I wanted to go into a bit more detail on is the composite pattern, just to kind of show how it applies here and how it improves not just code cohesion, but code reusability. So for those who aren't familiar with the composite pattern, it's essentially an object that's encapsulating, an object that's represented by or composed of a set of other widgets, and it hides their implementation details. So that's generally what it's about. Just in case you guys weren't familiar before I go into this example. So here's code reusability using the composite pattern. Let's say we want to design these three UI components. As you can see, these three look very familiar. They're very similar, I mean. All three of them are composed of disclosure panels. They have some specifics to them, like this one has a text box, this one has a hyperlink, this one a text box and a button, and etc. So they're slightly different, but they've got some commonality between them. When I say the word commonality, the thing that rings in my head is inheritance, because then that means I can put a lot of the common stuff in a parent class and then have each subclass specialize for whatever they need. The other thing is that this could be a composite because it's essentially composed of a disclosure panel and other widgets. So I'll represent these kind of specialized dialog boxes, or specialized disclosure panels, in a composite that will be reusable. So I was saying a parent class. So this is that parent class. This is the stuff that'll capture the stuff that's common between those three disclosure panels. So here's a disclosure panel widget. That's what's going to be wrapped by this composite. You can see here I have an extends composite because that's something we actually expose in GWT to kind of encourage the use of the pattern. In its constructor, it's just instantiating the disclosure panel with whatever subclass, whatever implementation the subclass wishes. And then I'm making this init widget call. This method is inherited from the composite class. What the init widget does is declare to the GWT compiler what widget this composite class is wrapping, right? So just so it knows what its DOM implementation looks like. So your composite has to be composed of a panel including other widgets or just one widget that it's wrapping, but you have to declare that, and that's the call to make. So this is the parent class. Now we have the specialized classes. So this is the contact class. This is the one that we're doing here. You can see in its implementation, it adds a label and a text box, and then returns those, instantiates the disclosure panel with that information. The same for the label disclosure panel. Same kind of thing going on here for its implementation. But you can see that now that these disclosure panel composites are made, these have become reusable components. So let's say someone else in my team, or myself, if I'm coding a different part of the application, I want to reuse some of these, I just have to instantiate one of these subclasses, and I automatically get that widget. So it's a good way to, as you're building out your widgets for your application, this is a great way to increase the reusability of your components and share them among your team. So composites are good because, as I said earlier, they let you easily reuse components. They also let you control access to the underlying widgets from which they're composed of. And in fact, we use composites in the GWT UI libraries themselves. So these are just some examples of widgets that we have in the UI libraries. And you can see they're all extending composite because they're all composed of various different other UI elements. OK, another GWT advantage, faster development. So that's through IDEs and code support. So earlier, as I was going through an example of a GWT application, you kind of saw me navigating through code in Eclipse. And that could give you an idea of some of the power that's available there. And for those of you who are familiar, you're already aware of it. So that's the kind of support you get while you're building your Ajax application. Now, for those of you who aren't too familiar with Eclipse or other IDEs and what kind of things are available, I just wanted to do a very, very quick demo of something called code refactoring. It's just an easy way to change your code without introducing any breaks, or not too many breaks. So let me do that. So I'll run through a real-life scenario. Let's say that for the composite classes I just created, I have those in my example here. Let me just close these. Right? So here, this is actually the same code that we just saw on the slides. These are the disclosure panel composites. So let's say I have my friend Thomas comes up to me and says, hey, you know, that widget was awesome, and I need to use it in my part of the application. But there's just one thing. You didn't expose the disclosure panel. I kind of need to get to it because there's some specific tweaks I need to do. But otherwise, the rest of your class is totally usable, and I want to use it. So then I say, yeah, no problem. I'll expose it to you, and then you can just call it and use the disclosure panel as you wish. So then I get into my code, and then I say, OK, so I got to create a getDisclosurePanel method so that he has access to this thing. And then I look, and I already created that method. It was really badly named the first time, and I called it getDisclosurePanel. Well, that was actually a bad mistake because getters and setters are usually typical for getting and setting member variables of a given class. So this is a bad name. So I'm going to change this and then expose a getDisclosurePanel method for my friend Thomas. But if I wasn't using an IDE, I would have to change that here, and change that here, and change that for any other class that's subclassing this. And imagining a large-scale application where you're dealing with hundreds and maybe millions of lines of code, that's just tons of manual changes you need to make that are liable to break your application. Well, using an IDE, what I can do instead is just go here, go to this refactor option, and rename the method. So this would have been better named if I call it createDisclosurePanel instead of get. So I renamed it. You can see in the parent class it's renamed. In this class it's renamed. And anywhere else where I would have subclassed this parent class, it would have been renamed there as well. And that's just one example of the kind of things you can do. You can just do tons of stuff with IDEs like that and the power they provide. And then now I just need to expose the getDisclosurePanel method from my friend Thomas. So that's just a regular getter method. It's kind of a common thing to do. So maybe my IDE could help me. And actually it can. So I just go here, source, generate getters and setters. For disclosure panel, I only want a getter, not a setter. And then it generates that for me as well. So this is actually turning out to be more of a demo of Eclipse than GWT, but just to kind of show you, just to show you the power that now you get to leverage because you're coding in Java and you have these tools available. OK. So another thing that allows for faster development and actually better QAing or quality assurance for your application is the fact that you can now put it through a standard test suite to test the application. So GWT actually supports regular test cases. You can write regular JUnit test cases to test the app. You can write GWT test cases, which are more specific to UI layout rather than UI functionality. And you can also write Selenium tests. So for those of you who raised your hands earlier and already used already started working with JavaScript applications, you might have encountered Selenium. It's a good way to kind of test those kind of applications. And in GWT 1.5, we've introduced a debug ID for all of our widgets. So now you can kind of track those. And if you've done Selenium testing, you kind of know why that's important. And now you can set a debug ID to your widgets and write Selenium tests as well. So this way you can write a suite for your application and run it through continuous testing. And finally, the other advantage is debugging in hosted mode, or debugging in bytecode. So we saw this earlier when I went through the run-through of how a GWT application works. But there's more to that, because we're going to make hosted mode actually a lot more powerful by taking it out of process. So what that means is, if you look back at this, the hosted mode browser as it is today, what I was explaining is that this is an embedded instance of your browser, right? So this is kind of great because you still get to see what the application looks like, and you get to debug in Java code. But there are a number of tools that exist in your favorite browser, for example, Firebug, that you might want to use at the same time as you're debugging. So with out-of-process hosted mode, that'll be possible. So what it is, instead of embedding an instance of the browser, we're designing a plugin that'll plug into the various browsers that we support. So for Chrome, for Firefox, for IE, etc., there'll be a browser plugin you can install there. The GWT hosted mode process, instead of interacting with this browser that embeds an instance, it'll interact with the plugin. So that means that instead of viewing your application through this hosted mode browser, you can view it through your regular browser, whichever one that is, and debug client-side as well as server-side, debug client-side JavaScript as well as the Java code where it originated from. So you get to debug on both sides and use other tools like live headers or that kind of thing if you use those as well. So that's making hosted mode a lot more powerful. And it's coming soon. We're still kind of under development with that. The IE6 version and IE7 is ready. Firefox, we're still working on the bindings. The core is all there. We're just working on the bindings for the different various browsers that we're supporting now. All right, so in summary, this is all the stuff I kind of covered today. And this isn't an exclusive set. There are a lot of other things that you can use in GWT to improve the performance of your application. There's internationalization available, which allows you to easily localize your app to different languages. Another example of something that's really useful and how seriously we kind of take performance, it's kind of the core design mantra for GWT, is something called the image bundle. So just to give you another example of something that's performance related, images you include in your application, for each image tag you have in your app, that's an HTTP round trip. So that's your user going from client to server again to pick up a resource and coming back. So what we decided is that if you could just download everything in one big chunk, have one round trip, right? The size of the image is not as important as the number of round trips you do to fetch each image. So if we could bundle that all together, right, and then only have it come to the client in one single request, that would be really awesome. And then so we did it. So there's an image bundle API that you can use, which bundles all the images in your application. It'll package them into one bundle that your client downloads, and then on the client side, it's going to use whatever native plugin is available for image handling. So for IE, it's like Alpha Image Loader, and it'll cut out the specific. It'll cut out the each section of the images it needs, and then place them in the right place in your application. That's actually using a CSS spriting technique. So some of you might be familiar with that. Maybe you've already done it by hand for JS applications. That's kind of abstracted for you as another example. So these slides will be posted online, so you can go through these again. If you guys are wondering about the different advantages, we also have the whole list online as well, so you can check it there. So with that, I wanted to go through what's new with GWT 1.5. So we've recently had a release about 3 weeks ago for GWT. So the first thing, and this was actually the most requested feature, is Java 5 support. So we now have support for generics, annotations, enumerated types, all of that stuff you have access to. And the richness of those annotations and everything that's available in Java 5 syntax, you can now apply to the JavaScript and Ajax applications you're going to create. So that's really neat, and that was the most requested thing. The other thing is easier JavaScript interop. So previous to GWT 1.5, one of the only ways that you could interact with external JavaScript or JSON data was by writing JavaScript native interface methods, JSNI, or what we call JSNI. So those methods are just a way that the GWT compiler allows you to kind of escape into native code when you need to and write handwritten JS as you would normally. So that was fine, but we kind of figured that it's a little bit still of a hacky way to kind of deal with external JavaScript. It'd be great if we had a better, strongly typed way of dealing with that. And now we do, through a technique called JSO overlays. So JSO stands for JavaScript Object. It's a class that's in the GWT libraries. Previous to 1.5, we had that class existing already, but it wasn't generalized enough. There were some specific things, too many things that were protected or final that you couldn't override, so that you could generally subclass it for your own overlaying onto JavaScript objects. Well, we've redesigned it since, and now in 1.5 it is very easily extendable. So you can extend the JavaScript object class, and you can overlay your subclass onto any other JavaScript object coming in from the wild, right? So for JSON data, for example, let's say I have some JSON data that's coming in. It has like product entries and product names and et cetera, all these different things. What I could do to interact with that in my GWT code is subclass a JSO, overlay that, declare the native methods that overlay that JavaScript, that JSON data, and then pick that up through that JavaScript object subclass in the rest of my application code base. That's actually really powerful, not only in that it's easier to interop with JavaScript, but now the GWT compiler can see your usage of the external JavaScript you're working with because it's through a strongly typed class. So what that means is more optimizations. Because let's say you have a JavaScript object subclass you made or a library that you're not using anymore, so that JavaScript object class becomes unusable, deprecated. Because GWT is an actual compiler, it'll do the dead code elimination on that, and it'll actually remove it from the code that's generated. It'll also do function inlining, and it can actually do that through a JSO overlay. So it becomes really powerful when you move things up to that level because you get to take advantage of the compiler optimizations there. In fact, we have our own libraries called Google API libraries for GWT. That's also maintained by the GWT team. And it's a set of bindings for different other Google APIs we have, so maps, gears, et cetera. And in those, our implementation to map to those are actually through JSO overlays. That's exactly what we're using. So if you need a reference implementation, you can just see the code there and see how we're overlaying to those APIs and then do it for whatever other JavaScript libraries you need to interact with. The other thing is an enhanced DOM class. And now we have almost full specification compliance with the current DOM API. So we've exposed that before, but it wasn't fully featured. So some people had to do some kind of hacky things to get around that. Now we have almost full support for all the methods you can expect. So if you've done a lot of document dot whatever method and are used to all the things you have available there, you can do that in GWT in strongly typed code through the DOM class that we now have. Also, the calls that you make there are going to work cross-browser as well, so you don't have to worry about that when you're dealing with DOM interactions. And again, the other advantage there is that since you're making DOM API calls through, again, the strongly typed class, which is visible to the GWT compiler, it can also see those usages and then optimize them as well. So it's always to your advantage if you can, to bring up code to your GWT code base, so that's visible to the compiler. And finally, better application performance in general. So every time we move from one version to the next, the design mantra of the GWT team is that the next version has to be faster, has to generate faster applications. There's a number of different compiler enhancements we've introduced in 1.5. A lot of them were actually contributed through open source community members. So they've contributed that back to us to make for faster applications and better optimizations. And from the benchmarks we've run on our samples and some reports we saw from external developers who are building GWT applications, we've seen speed improvements from 20% all the way up to 200%. So it's kind of the biggest jump we ever saw for performance improvement from one to the next. And as we go on with later versions, we're going to keep making performance improvements. And again, you can just take advantage of those by recompiling with the latest version. All right. So with that, I'd like to kind of invite you to this website here. That's the GWT homepage. You can go there to find a lot more information about GWT. We have a lot of new documentation we wrote on for GWT 1.5, both for beginners who are just getting started. We have an excellent getting started guide that walks you through creating a GWT application from scratch, all the way from scratch to interoperating with JSON data to internationalizing it. It walks through the whole thing. So you get to get a good tour of all the different libraries available and seeing what GWT development actually looks like. We also have more documentation on more in-depth topics. So deferred binding as an example, which is something I covered today. We kind of had a hard time explaining that to general developers who just come to the site. But we've had a lot of people questioning about it and saying they wanted to learn more about it. So we kind of did some documentation on that as well. Memory leak prevention in JavaScript code and that kind of thing. So we've enhanced documentation for more advanced users as well. All right. So with that, I wanted to open the board to Q&A. I know this was kind of a general session. I'm sure a lot of you came to this session for specific questions on GWT. So I'd like to invite the floor to kind of ask any questions you guys might have for GWT or applications you're about to build. Yes, and there'll be a microphone being passed around, so just to make sure we can hear.
Hi.
Hello.
We're actually developing an application contacting an application server which runs a GWT3 implementation using Hibernate and so on. And the problem we face is that all Hibernate POJOs with bags inside, for example, many-to-one and one-to-many.
Right.
We have problems and we have to create DAOs for that and so.
Right.
Is there any general approach to solve this problem?
There is a general approach, and there's a more specialized approach, and I'll talk about both of them. So the thing is that, and I imagine you guys are using GWT RPC, right? Okay, cool. So in GWT, there's a GWT RPC subcomponent that lets you use Java on both the server side and the client side, and lets you make kind of RPC calls. So to you, it looks like you have the same POJO, the same regular data transfer object, going from client to server, and you deal with it in Java code. That object is actually serialized by the GWT compiler. That's going on under the hood. So it serializes that into JSON data, into really aggressively optimized JSON data, in fact. So it's the smallest size possible, sends that over the wire, and then back and forth like that. So that you don't have to, you can deal with the Java object, the POJO on both sides. Now for the case of Hibernate, Hibernate objects have a lot more information associated to them. For example, Hibernate itself is tracking them. And there's also the concept of things that can't be serialized, right, in the JavaScript world. So when we have a POJO that's going back and forth, there are things that we can serialize, a collection, for example, an array list, etc. Those are things that have roughly equivalent representations in the JavaScript world. So we can map those. And that's actually in an emulated JRE. You guys can read about that. We have a whole API doc on that shows what we emulate. For Hibernate, there's things we can't. And there's object graphs that it loads up as well. So if you're loading a Hibernate object, how do you send all of that over the wire? Well, the general approach that most developers have taken is kind of sadly to make mirror objects, or DTOs, that mirror your Hibernate object. So that's one way to do it. If you don't have too many of those objects lying around, then that might be a good way to kind of handle it. But it's kind of a lot of work, especially if you have more than just a few Hibernate objects around. So someone went through the hassle of taking that work and kind of generalizing it and abstracting it in a library. So there's the Hibernate for GWT project. It's spelled exactly like Hibernate and then the number 4 in GWT. So that's a library that's also made by other open source developers. They've created that and kind of create proxies under the hood for the types you're trying to send over the wire. So then you don't have to worry about the fact that a regular Hibernate object can't get serialized over the wire because of all the information it contains and the object graphs that it loads up. So with Hibernate for GWT, you get to specify in your Hibernate XML, it has specific rules that you can specify for when types are being transferred over the wire, and also handles making a proxy DTO that it can send over. Is that answering the question? Okay, great, thanks. All right, more questions. All right, from the back there.
I haven't really worked with GWT yet, but I have a question. Can you create complete standalone apps with GWT, like you can with Sprout Core or Cappuccino?
I'm not completely familiar with Sprout Core. So what exactly do you mean by complete standalone apps?
Well, apps that run completely in the browser. For example, with Sprout Core, I can build open social apps that don't need any backend or anything.
Yeah, you can. You can. In fact, if you're just looking at the code here, right, this sample application, or the one I'm running here, there's no server-side stuff going on here. This is just dummy data. It's just all like filler data that I have written in, that I've hard-coded. So it's not coming from a database. There's no database connectivity going on here. It's just all client-side. So if I wanted to interact with, say, maps, for example, which would just be through JSON, I could include that here, or any other thing. So you can just do client-side development if you like. If you're interoperating with Google Gears as well, then you have storage on the client side as well. And then you can have a full standalone app all running in the client with no server connectivity, except for the initial serving of the resources for the HTML and JavaScript. Yeah, that's it. Yeah. Great. More questions? Any questions? Yes. Oh, hold on. The guy with the mic is just going to come by just to Gregor.
Now the RPC question. Well, we don't have a Java backend, and we want to use the RPC mechanism, and couldn't find any documentation about and how the protocol is implemented. Okay. Is it a good idea to try to implement it? I saw we especially have a Python backend, okay, and there is some project going on, but we want to try to do it ourselves. Okay. So is this good, or do we have to change code all the time if a new version of GWT is coming out? Right. My suggestion there, so there's two ways to handle that. One is better than the other. So I'll go through the worst one first, then go to the better one. Right? So you can use RPC, GWT RPC. It's going to be a little bit tough because you'll have to write your own custom field serializers. And there's some people who have done that for different backends, and it's kind of a rougher road. So you can look into that. If you look into a custom field, like if you download the GWT distribution, just do a search within the classes in Eclipse or whatever, just to look through some of the classes, and you'll see something called custom field serializer. That's what we use to actually serialize the data going back and forth from the Java POJO objects. Essentially, you could try to plug in your own custom field serializer to handle that, but for the Python environment. But that's less ideal. What I would say would be best is the Python data you're exposing out to the client. Is that JSON data? Or what kind of data is it? Is it XML or like a... For now, it's JSON data.
For now, it's JSON data. Actually, that's a great way to go, because since it's coming to the client and that's what it's running, I would say that's the best approach for data format that you send over, and it's less heavier than XML as well. So, so what you could do is that there's a general request builder class in GWT, right? It's an abstraction over an XHR, and you can do something called requestbuilder.sendRequest, and it'll just send a request to whatever URL you say. You can pass in parameters, URL parameters. You can set headers on it as well, onto the request. So what you could do then is, using the request builder class, create your own class on top of that wraps communication for your application, like what communication looks like for the server side. For example, when your Python backend receives a request, what kind of URL parameters is it expecting, and what will it read from that, and what will it do based on those? So you can build a class over the request builder that has some convenience methods for, like, make payment or etc., whatever you like, and pass in the information there. Then when you make the call, extract the information, add it to a URL parameter, wherever you like, send the request through the request builder, make the request builder.send request call. It'll send the call to your Python backend, and what you'll get back is JSON data, right? The JSON data you get back, to interact with that in your GWT code, you can either do JSNI, JavaScript Native Interface methods, so you can work with it through the native method, or you can do a JSO overlay, which is what I was explaining earlier, the JavaScript object subclass. Create a subclass that maps to that JSON data, right? And that way in your GWT code, once you get the request back and you get the data back, you can from there you can work with the JSON data that came back and then handle it from there. Is that generally a good answer? Is that what you're looking for? Or?
Yeah, we just thought if there is we used a JSON wrapper already that's for JSON RPC.
Okay.
There's a library too. We improved it a little bit,
right.
And we don't want to. We try to avoid to write mappers by hand for classes or for different objects, so that we just can pass arrays of primitive types and such things.
Right. In that case, so the wrapper that you're working with, does it automatically generate JavaScript for the clients as well then? Because when it's generating the JSON data, is it stuff that's easy to work with, or is it like different? Is it differently named? Is it optimized JSON data, or is it just regular JSON data that's very clearly named, very easily readable?
It's regular JSON data.
Okay. So then overlaying with it or interoperating with it in just regular JavaScript should be fine too, because that would be the JSNI code that you would write. So you could write a native method and just interoperate in regular JavaScript, and that way you just interact with the JSON data in a raw way, in a raw fashion, and you wouldn't have to create any JSO overlays. But I would say that it would lead to better, if you have a lot of data, especially, and a lot of different types of information coming back, it would lead to a more efficient app if you did use a JSO overlay, because then the GWT compiler can optimize the usage of it. So yeah, those are the two techniques you could use, I suggest. Yes?
What about HTML coming from an HTML designer, and what about the life cycle with new HTML design and new code and so on?
Right. So with the new HTML design, I guess you're referring to HTML5? Are you referring to HTML5? Okay. Well, firstly, there's the spec to come out with for HTML5 itself. And then once that comes out, then all the browsers have to be able to follow and implement that in their DOM. Until that time comes around, I mean, GWT's stance is kind of, for the time being, in the current state of things, it's a good solution for the current affair among browsers and specs. Things are going to improve, that's for sure. And right now, browser development is a nightmare. So once HTML5 does come out, and it does get pushed out and becomes more popular, I can see that GWT it's a solution that we can keep improving, but depending on how that plan plays out of HTML5 coming out, how many browsers actually adhere to the standard, and if they actually improve the web experience in general, if that happens, it's very possible that you won't have to deal with these kind of browser quirk hacks anymore, and et cetera, and all these kinds of things. But it's hard to say what's going to happen, because as we've seen in the past, standards have been defined a long time ago. XHR was available a long time ago. CSS was available a long time ago. But browsers never, the companies behind these browsers, the people implementing these DOM implementations, they never came to an agreement. And until that time, you need to deal with an abstraction for that part. So I think that answers in terms of your question about HTML standards and where they're going. The first question you asked was how to deal with HTML for designers, right? Okay. So for a designer, the way we kind of currently expose GWT for designers so that they can style the app properly is strictly through CSS. Now that isn't ideal because of course they don't want to have too much to know about the Java widget. So the person who's coding the GWT application, they code all their Java stuff, and after they code a widget, they can do a call called set style name, and then pass in a CSS style name to a given widget. And that's where the designer comes in, who they're the ones who code that style, that CSS class. They code up the style for that. So that's how they plug in the current state of GWT. What we're doing to kind of improve that is we're coming up with declarative UI. So what that's going to look like, it's a very XML-like syntax where you will have element names that are bound to your GWT widgets. So then the designer can just play with the layout and styling in that XML kind of specification format. And it's actually making links to your GWT code, so that way the designer doesn't need as much knowledge about what's going on in the Java world of things, and not that they need too much knowledge now. They just need to apply the style name, but we realize it's not completely ideal for someone who wants to do the whole layout themselves as well and all that kind of thing. So declarative UI would go a long way in that respect. It's currently under development. We have a design doc already online for that on the GWT project page. So that's not the link I showed you earlier. That's our homepage. The project page is on project hosting. So code.google.com/p/webtoolkit. /webtoolkit. Yeah. So you can find out more information about that there. Cool. We have time? A few more minutes? Finish? Last question?
Okay.
All right.
How does the output of your compiler compare to handwritten JavaScript code? I mean, have you tried to implement a widespread library with your Java code to a compilation? And maybe you found out that some parts of your compiler output are slower than the handwritten code. So is there any spot where we as developers need to take care?
Not necessarily. If I understand the question correctly, you're asking that, so sometimes in some cases, did we ever find that the GWT compiler generated JavaScript that was actually running slower than when someone wrote by hand? And then in those cases, what do we do? That kind of thing. All right. So in general, when you're just starting out, let's say I'm just starting out a prototype of my application. Chances are your handwritten code could be more efficient, right, when you're just starting out. But as the complexity builds up for the application, the way the graph looks like, drawing it the direction you guys are seeing it, as complexity grows, this is what happens. You start going up like this, and then you start flatlining, and then you're not paying any more performance costs. Did everyone follow my tracing there? All right. Anyway, so as the complexity grows, your performance starts flatlining, and you're not paying anything more for what you're adding to your application. In handwritten JS, the way that looks, it's a slower slope, but then afterwards, as it gets complex, it'll go flying up like that. So for the GWT compiler, when you're starting with something that's a prototype, it's very possible that because of the extra bootstrapping code that we have, some of the verbosity there might lead to a slower app than you could do by hand, but only at the prototyping stage. When you actually start building it out and adding more features and components, our take on it is that it's vastly superior. And the analyses we've done and the benchmarks we've run have shown that. Within Google itself, actually, a lot of teams have been some redesigning, and I can't disclose which, some redesigning and some implementing new projects with GWT. So Google Health is one example. There's something else that's very important that's coming out that'll be redesigned. And there's a lot, like 60 or 70 other projects happening internally. So I help out with a few teams internally as well who are working with GWT and also evangelizing internally. So I guess some of that as well. So just to show what the uptake is like and what kind of analysis we do on it. And we're pretty serious about the platform. Yeah. So is that the last question? No more time? All right. Well, I'm sorry that there's no more time left. But if you guys have any more questions, I'll be hanging around for a bit here. Do we have time for it? One more? No more time? Just come see me afterwards. No problem. I'll be hanging around for a bit, okay? So, thank you.